Welcome back to our B6.2 race buggy build series. In part 5, we have more parts for our buggy plus cooling fan issues to address, and then we'll show you how to fix it. In case you missed it, in the previous part 4, we finally changed our motor cooling fan position from the factory side guard mount to the back of the chassis. With this modification, the fan has better access to air and should cool the motor better. And we tested it with a few 5-minute timed runs on the track. Now with the fan in the stock factory position, motor temps after 5 minutes were 195 degrees. But then once we changed the fan to the back of the chassis, motor temps were 165. Now dropping motor temperatures 30 degrees is pretty dang significant, especially when the outside ambient temperature was 108 degrees. In really high temperatures, brushless motors can be heat washed, leading to power fade. And in really extreme temperatures, the motor can experience irreversible damage if the temperatures are high enough. Now this is because brushless motors commonly use neodymium magnets inside the motors, and the maximum temperature threshold for those magnets is 80 degrees Celsius or 176 degrees Fahrenheit. Temperatures beyond that limit are going to gradually reduce the magnetic strength of those magnets, which is what that power fade is. And then if temperatures are pushed even higher beyond that, the magnets will experience irreversible loss of magnet strength and permanent damage. So that's why you don't want to ever overheat your brushless motor too much, because those magnets will become damaged and the power will just fade away from what it once was. As you guys know, brushless motors are expensive, but they're great investments because if you take care of them, they will last you forever. And they will retain the same amount of power that they originally had with virtually no maintenance. So changing our fan position to achieve better cooling temperatures on our motor was a really great move to make, but it did have this side effect. Now, as many of you commented in the last video in part 4, the issue with our fan there was all due to the magnets in our brushless motor, the very thing we're trying to cool down. Now what happens is, since the brushless motor has magnets inside and so does the fan, if the two pieces are too close together, they can experience magnetic interference. Now it doesn't happen with all fans and it doesn't happen with all motors. There's so many different combinations of different motors and fans you could put together and different magnetic strengths. So some people may experience this issue while others will not. Now since stock motors are limited on the number of wire windings in that motor, and in our case 17.5 turns of wire, what motor manufacturers do to try to make that stock motor faster is they just use more powerful magnets. This isn't so crucial with modified motors because you can control the power output with the amount of windings. If an 8.5 turn isn't fast enough, make it a 7.5 or a 6.5. So the magnet strength with modified motors isn't so crucial. But with stock motors, those magnets, and specifically their strength, is really important. And that's why with some stock motors and the magnets used in certain fan combinations, you're gonna have a lot more issues with the fan sputtering, stopping when they're too close to a real powerful stock motor. Even just the position of the rotor inside the can, where it is and how it's lined up and how that affects the magnetic strength and force inside that motor, can also affect the fan. You can see here I'm spinning the tires to spin the rotor in different positions, and it is having a direct effect on our cooling fan. So, how do we solve this? Well, it's really easy. All we need to do is move our fan back a little further. And with that, we bought some new parts with our $50 budget. So the first item we bought is this Exotech clamping angled motor fan mount. So we basically need a way of mounting our fan further away from the motor, and we've essentially run out of chassis space to stick the fan down. It's already all the way at the edge of the chassis, so we can't push it back any further except this will allow it. Now we've already mounted up our fan with one of these clamping angled fan mounts. And you'll notice we added this long blue aluminum caster hat bushing. It was left over from the kit, and it spaces back the fan a good amount. So the fan is now floating above the chassis. It's really super sturdy and secured. You can pick up the car by the fan, and this provides just the right amount of space that we're not having any more fan issues. Now keep in mind that if you try this with your buggy, you may need more or less space depending on your motor and fan combination. You might just need to experiment a little with it. With the fan pushed back more, we did have to trim the body a little bit because you can see the fan is really kind of sticking through the body now, but it's not a problem. It clears everything and there's no binding. The fan's not hitting anything. It's not an issue. We did go out and test the temps just like before. It was 95 degrees outside with the ambient temperatures, and after 5 minutes, the motor temps were about 150 degrees. That's a increase of 55 degrees. Previously, when it was 108 degrees outside ambient temps, our motor reached a maximum temperature of 165 degrees. That's an increase of 57 degrees. So this has been a really great way to cool down the motor, keep those magnets cool, and keep those expensive stock motors in tip-top shape. So with this brand new fan mount, we're actually going to give this back to the AMain Hobbies owner and CEO, Kendall Bennett. He gave us one of his. That's what we're using in the car now, so we could test and experiment with it before this video. And this Exotech fan mount cost $19.95. Now the next item we added was a lightweight pinion gear. We just added a 30-gram brass weight to the front. That's adding a lot of weight, so we might as well knock it down a few grams of rotational weight. Now this recommendation is actually coming from a fellow racer, Travis, out there at our local Silver Dollar RC Raceway, where at the last race he was showing me his Trinity ultra lightweight aluminum pinion gear that he uses, and that thing is super nice and sweet. So he inspired me to check out some different pinion gear options, and we pulled a few and we weighed them. Now what we have here is a Team Associated aluminum pinion on the top, a Trinity ultra lightweight in the middle, and a Polypro hybrid pinion gear on the bottom. All of these are 30-tooth pinions and 48 pitch. Now on the scale, the Team Associated aluminum pinion gear is just around 1.9 grams, pretty much 2 grams. The Trinity ultra lightweight aluminum pinion gear is right around 1.2 grams. And then lastly, our Polypro hybrid pinion gear is about 0.9 grams, or 9/10 of a gram. And I know these weight differences are pretty small and minuscule, and it probably doesn't seem like it matters that much, but every gram makes a difference, especially rotational weight for a stock buggy. Now it's interesting, the Trinity ultra lightweight pinion gear is quite a bit lighter than the Team Associated, and it's really not that much heavier than the Polypro, but being that it's a solid aluminum gear, it probably in the long run will hold up a bit better than the Polypro. So those Trinity pinion gears are pretty dang impressive, and had the 29-tooth Pinion been in stock when we purchased this stuff, we probably would have picked it up for our buggy since we need a 29, but instead we went ahead and picked up the 29-tooth Polypro pinion gear, and this guy cost $6.99. Now the last item we picked up for part 5 is just some shock fluid. It's 35 weight, so we can mess with our shocks a little bit. This happens to be the only 35 weight fluid that's in stock right now, and it costs $4.99. What we're gonna do with this 35 weight is we're gonna put it in our rear shocks, and then we're gonna take the included 40 weight fluid and put that in our front shocks. Now, as the car sits right now, it only has 30 weight fluid in the front and rear. We built it just as the manual said, even though in the back of the manual, the setup sheet actually says to use 30 in the rear and then this 40 in the front. So I don't know if that's maybe a typo in the manual to not say 40 and 30, but with the really high heat we're experiencing, those oils tend to thin out and 30 is just too light. So I'm thinking with the 40 in the front and the 35 in the rear, that should help us out on the track. So we're gonna swap out our fluids and the shocks, and then we'll change out our pinion gear, and then we're gonna check our ride height, and then recheck our camber, and then we'll call it good. But we're gonna take care of that off camera, so I'm gonna leave you guys here. Thanks for following along with this buggy build. If you have any recommendations or suggestions for this car, leave us a comment down below. Give this video a like if you liked it, and hit that subscribe button if you haven't. I'm Brett from AMain Hobbies. Thanks for watching.